The name Perkins carved in stone. Below a Gothic tower, a boy navigates with a cane. A title: Cerebral Visual Impairment, a brain-based visual condition, with Amanda Lueck. Cerebral visual impairment is a brain-based visual condition with a wide range of manifestations that are different from ocular visual impairment, in which sight problems are caused by one or more parts of the eyes not functioning properly.
The visual brain is much more than the visual cortex, which is the back of the brain. There are also associative areas of the brain that can be affected by brain injury, and so cortical visual impairment really refers to the visual pathways going from the eye to the visual cortex. Cerebral visual impairment can encompass other areas of the brain and also lower parts of the brain like the cerebellum. They started using this term when they looked at children who had periventricular leukomalacia, now called periventricular white matter damage, and found that those children had problems with their vision that weren't associated with just the visual cortex, and started calling for a new term, cerebral visual impairment. Some mechanisms in the brain are just not there, and so the brain will make adjustments, and the child will make adjustments. In some instances, there might be some rewiring. Again, the research on this is very sparse. We're right at the beginning of understanding cerebral visual impairment. The information is going to be exploding over the next decade or even sooner, I hope. But yes, the wires aren't going certain places. The brain is compensating, the children are compensating, and they're functioning, but they're being misunderstood because they're being attributed to having autism or learning disabilities or developmental delay or cognitive issues, when it really is a processing problem. What we need to do about that is also in its infancy. And so that's what makes this topic so fascinating and so difficult, but again, so important to address.
Fade to black. A title: Vision Assessment for Cerebral Visual Impairment.
Cerebral visual impairment can manifest in many different ways, and people are still learning about how cerebral visual impairment manifests. And the theoretical bases behind these manifestations are still being worked out. One way of looking at it was proposed by Gordon Dutton based on work by neuropsychologists Milner and Goodall, and probably people before those two researchers, based upon the dorsal and the ventral streams. And that's a really simplistic way of looking at it, but it's very practical.
We see a two-dimensional color illustration of the left hemisphere of a human brain. The occipital lobe, which is located at the back of the brain and contains most of the anatomical region of the visual cortex, is shaded in bluish gray. The temporal lobe is situated along the lower left side, and an arrow depicting the ventral vision stream extends from the occipital lobe along a portion of the temporal lobe. That portion is shaded green. Located just above the occipital lobe and shaded in pink is the parietal lobe. An arrow extending from the occipital lobe up into the parietal lobe represents the dorsal visual stream.
The ventral stream is the what system. It tells you, I know who you are from talking with me. I can identify objects and shapes and words, and for that I use the ventral stream. There are probably other things dealing with the ventral stream that are very specific. People with ventral stream disorders can get lost. They have spatial agnosia, topographic agnosia. If you don't know what you're looking at, you don't know where you are. The dorsal stream, which goes to the posterior parietal lobe, it helps you understand where things are. So I'm talking with you right now, and I know where you're sitting, and if I wanted to get up and shake your hand, my arm would know exactly where to go, and my hand would know exactly where to go to shake your hand. The dorsal stream works in conjunction with the frontal lobes to work all those things out. So there are different patterns with the dorsal stream, which is the where system, and the ventral stream, which is the what system. A lot of issues with cerebral visual impairment are not picked up until the children are older because they're more subtle. When children are born and they have no problems with their ocular mechanisms, they can often be identified as having cortical visual impairment because they're not seeing and there's nothing wrong with the eyes or the system going back to the occipital lobes. And often those children have profound visual impairment. For children with the subtler forms of visual impairment, it doesn't come up until they're going into school and they're learning how to read. They may appear clumsy. They may not be doing things in the normal way. They may not recognize people. They may come up to strangers and go, "Hi, Mom, hi, Dad," because they may not recognize faces. They may have trouble walking around on uneven surfaces. They may have trouble going particularly downstairs. They may have trouble picking things out from a crowd or sorting clothes that are in a pile because they have some other issues, problems with visual crowding, visual clutter. The technical term for that is simultanagnosia. The technical term for not being able to recognize people from their faces is prosopagnosia. And so they may have these other issues. They could have full visual fields, but could have visual neglect, where they have visual inattention to a part of their visual field.
In a video clip, we see a young girl who wears purple glasses sitting at a desk with her TVI. On the desk, slightly to the girl's left, is a book with colorful full-page illustrations of ducks and ducklings. The girl is being asked to count the number of ducks she sees. It appears that she does better discriminating the figures once the book is moved directly in front of her. Even then, she appears to favor the right visual field, pointing only to the ducks on the right, identifying a large illustration on the left page only after the book has been folded to display that single page.
Two children with cerebral visual impairment can have very, very different views of the world. And so it's not an easy thing to understand. It's fascinating, but more important than that, we have to be able to understand how it manifests in individual children so that we can help them to the best of our ability and they can grow to their full potential.
Fade to black. Common issues associated with cerebral visual impairment.
Well, it's very important first to have an assessment for ocular visual impairment, because we need to be sure that all those corrections are in place and we understand if there's any need for refractive correction, if there are any field loss related to ocular visual impairment, if there are any contrast sensitivity issues, the ability to distinguish subtle shades of gray, for example. Some of these things can be affected also by cerebral visual impairment. Then with cerebral visual impairment, many young children are not tested for accommodation problems, and many children with cerebral visual impairment do have accommodation issues that need to be corrected. So they have difficulty seeing things up close. And that's so important for young children, especially for those doing pre-reading, reading. And if they can't see up close, they're going to have problems reading, and nobody will know why. And that's, a very simple issue. They can have problems with their ocular motor system, just as they could with ocular visual impairment. So again, the line blurs because, is it cerebral or is it ocular?
In a video clip, we see Amanda Lueck sharing a puzzle with large shapes and various colors with a young boy. The boy is visually impaired and wears a hearing aid. He also wears glasses, an indication that he has undergone a hearing and vision exam, and there have been ocular vision corrections as well as auditory corrections.
I've been looking at children now myself. I've been going into the schools to see if I can come up with an answer to the question of what do I do in an assessment. And I come with a whole battery of tests and a whole package of information in my mind. And I will go with the child in terms of how I assess the child. I'll get the basic information. If I am administering formal tests, I look at not just the outcome of the test, what's the number. For example, if I'm doing a line visual acuity test, I should mention that a number of children who have CVI have normal to near normal acuity, but they have some other functioning issues. There are another set of children who have normal to near normal acuity and operate at their typical academic level. So we're seeing a whole array of children. So if I'm seeing a child who can do an acuity test, I will ask them to do the acuity test, but I'm almost not so much interested in their acuity, although that's nice to have, as to how they operate on the test. How do they hold their head? How do they look at the letters? Do they skip any letters? Are there any hesitations? How do they go from one line to the other? Do they use their eyes? Do they use their heads? Do they shift their body, which is, can indicate a number of things? And then I will explore those things that I find even further through additional testing or observation.
In an attempt to observe the ability of a young boy to track an object visually, Amanda Lueck presents a light wand with a glowing red plastic cube to a young boy. The boy, who sits in a curved chair on the floor and leans back, is visually impaired.
The trick, the intelligence, is to have enough information yourself to know what you need to look for and how you need to look for it. And then the test is a tool that you use, that you have in your battery. It's, like your screwdriver and your hammer. You pick out different tools for different things. So it's a hard question to answer, to say which tests do you use. So even the tests that I use in different ways with different children, because they're going to operate in different ways. So with one child, I might have them do a repeat reading of a test. Say I'm doing a sentence reading test to find out what print size they would best use. If I felt that there were a lot of hesitation on that, I would ask the child to repeat the test, and if they did better on the second reading, that gives me a lot of information about the child.
Fade to black. Additional assessment considerations.
I thoroughly believe that children with CVI need a multidisciplinary assessment. As I said, I worked in the clinic and did the functional vision assessment, worked alongside an incredibly fine pediatric ophthalmologist, and I felt that I needed to refer children for additional assessments by orientation and mobility specialists, by psychologists or neuropsychologists, by optometrists, by many, many other speech language pathologists, physical therapists, occupational therapists, and depending upon the child, I would have to then determine which specialist they would need the full assessment from, because CVI affects so many things. One of the things that I didn't mention earlier about a manifestation of CVI is that many children with CVI also have auditory processing problems, and those need to be picked up. And if in a screening a child appears to have a possible auditory processing issue, they need further testing by a specialist who's able to do that to get a full picture of how that child operates. So, I operate as a teacher of the visually impaired. I know that if I saw a child with CVI now, I would want that child to have access to a lot of additional testing. I could maybe point the direction for the other testing. I could talk about their functional vision. If I had enough information from the optometrist and ophthalmologist, I would want to find out about what's called higher order visual processing. I could do some of that myself, and some of it I would need to have an evaluation by a psychologist or a neuropsychologist. So it can be misdiagnosed with autism. For example, children with autism have difficulty reading faces and facial expressions, and so do children with CVI. It can be misdiagnosed as a learning disability. I saw one child many years ago who was diagnosed with that, was put in a visual reading program, but he couldn't read visually, and he was thought to have an auditory processing problem, and in fact his auditory mode was the best mode for him, and after a multidisciplinary assessment the school changed his reading program and he was able to stay on grade and do very, very well. So that can happen. It can be, the child can be diagnosed as having behavioral issues. If they get flustered easily, a story of a child lashing out when another child ran up to him very, very quickly because he was startled. And actually, he did not see the child until the child stopped moving. One of the things about CVI is that some children with CVI can see fast-moving objects and some children can't. The speed can be affected by CVI. They can be thought of as just clumsy and awkward, and that can have social implications. The families can have difficulties because they may not understand what's going on and go, well, here's my beautiful child, what's going on? If they're not given appropriate interventions, then they are kept in classes for learning disabled or special classes for mild, moderate disabilities, and they may not be getting the appropriate interventions that they need so that they can move on through school. So it's very, very important that the diagnoses be accurate, not confused, because a child could have CVI and autism. A child could have CVI and learning disability. It really takes a team to tease this out.
In a video clip, we see Amanda Lueck attempting to conduct a vision test with a young boy who is visually and hearing impaired and wears a hearing aid. She sits across from him at a desk and presents acuity cards, one of which has a line drawing of an apple. After the exercise, Dr. Lueck discusses her observations with two TVIs who regularly work with the boy.
So we're not in this alone. We have to be collaborative and have a multidimensional assessment. And the multidimensional assessment leads to a multidimensional intervention plan. A child isn't just eyes. A child is a whole person, and vision is used for cognition and for moving. So we want to know, what does the child understand from what they see, and how do they process it, and how do they apply it? How does a child move using their vision? How do they process it, and how they apply it? And so it takes a team to be able to figure this out. That's why it's not an easy answer.
For more information about cerebral visual impairment and assessing cerebral visual impairment, you can check the following resources. Chapters 11 and 20 of Vision and the Brain, edited by Lueck and Dutton, and available at AFB Press at afb.org. Chapter 6 in Cerebral Visual Impairment in Children, Visuoperceptive and Visuocognitive Disorders, by Zeal and Dutton, and the paper by McIntyre and Bayon, Cerebral Visual Dysfunction in Prematurely Born Children Attending Mainstream School, which can be found in the Journal of Clinical Electrophysiology and Vision, August 2013.